All right, this is lesson 118, Algebra 2, and this is logarithmic equations. We've done some with logarithms, and enough to maybe get your feet wet a little bit, but if you remember, logarithms are exponents. So when we're given something like the log with a base 2 of 8, that equals 3. Because in exponential form it can be written as 2 cubed equals 8. So this right here is actually like the answer. That is what this to this power is going to equal. So that 8, that number that's there, is called the argument. If you can read my writing there, which you probably can't. And if you remember right as well, when we're doing logarithms, like when I have log of x minus 2, this is the argument. This number that goes right there, that base, if it isn't there, it's assumed to be a 7. All right, so if we were to kind of erase some of this junk that I have here, if we were to look at or compare two logarithms, because that gives us a chance to put an equal sign in there. And if we had something like, well, let's just write it this way. 3 squared equals 3 squared. Why is that true? Well, that's true because our base number here and here are the same, and our exponents are the same. Now, if I were to write this in logarithmic form, okay, and I were to put an x here, and if I did that, okay, what does that mean? That means that if my bases are the same, then my answer has to be the same if my exponents are the same. So let's look, for example, at something like log 5 of x plus 4 equals log 5 of 7. All right, so a key thing here is that my bases are the same. All right, if my bases are the same, and this is very, very important here, I can throw this out and this out because they cancel each other. And I'm left with x plus 4 equals 7, which makes it really, really easy then to find out what x is. All right, so let's look at a couple rules. And we've pretty much already looked at these rules if I remember right. If I haven't talked about these rules, well, we're going to learn them. If you already know them, we'll learn them again. It doesn't hurt to help or to learn or keep up on them. So if I have the log of 5, so remember the base is 10 if I don't write it down, plus the log of 7. That means that's equal to the log of 5 times 7. Okay, because you remember when we've done things like, well, if I took 10 squared times 10 cubed, that equals 10 to the 2 plus 5. Remember, you add the exponents. That doesn't look like a 5. You add the exponents. Okay, it's the same thing here. This has already been figured out. The exponents are already added. To go to the other way, to reverse, we multiply the 5 times the 7, or log base 10 of 5 plus log base 10 of 7 equals the log base 10 of 35. If I have, and this is just stuff to remember. This isn't stuff that's like, oh my gosh, how did he do that? How did he figure it out? They're just some rules. Okay, so if we have an x plus 2, and plus, and the log of this one is also 8 of 3, that is going to be the same as log with the same base as 3 times x plus 2. So we just multiply those because, again, remember, logs are exponents. Okay? When you multiply, you add. When you add, you multiply. So when you're going from two logarithms down to one, and there's a plus sign, you multiply them. If this were a minus sign, that means we had divided. So let's go into some stuff with some subtraction here. If I had, again, log 3 of 14 minus log 3 of 9, and again, the base has to be the same. That's the same as log 14 over 9. Oops, sorry, I forgot my base there. Okay? So it's just remembering subtraction and dividing, multiplication and adding, and you should be okay. Now when we have something like this, remember that's going to be 10 to the 15th because of the power rule. All right, if we were to write this logarithmic, and again, you just have to remember that this is the way it works. If I have log 10 to the 100 to the 4th power, that can be written as 4 log 10 to the 100. Okay, so all I do is move the exponent to the front. If the exponent is in the front and I need to make a change, I can move it back over there. It just kind of depends on what I'm doing, on which direction I'm going to go, what rule I'm going to follow. So if I've got x log 10 of 100, that's the same as log 10 100 to the x power. Okay? All right, so let's try doing a few of these. And don't you hate it? I mean, I sit there and teach you all of these principles, and you're just kind of following but not really knowing why. Well, that's when we come into some actual problems here, so we can actually use this stuff. All right, so key thing when it comes to this, you're going to look and see that all three expressions have logarithms. Then you're going to look at the base, and the bases are all the same. So since all of that is true, we're going to write this as x plus 7 times 2 equals 20, and do the math to find the x. Okay? So basically what I'm saying here is when the logs are in all of the terms and they have the same base, just cross them all out and you get x plus 7 times, because of the plus sign here, times 2 equals 20. Don't forget that plus means multiply, minus means divide. All right, so if I have log of 14, and I've got an x plus 3, and then I have a minus log 14 of x minus 3, and that equals log 14 of 7. Again, cross that out, cross that out, cross that out. Minus means divide. And then you go from there and solve for x. Okay. All right, let's look at, looks like just one more. 3 log base b of x equals log base b of 64. Okay, so I don't care what the log base is, as long as they're the same, they go away. And what happens then, when I can't make that log go away until I do something with that. So that means that 3 goes up there, and that equals 4. So that goes up on that, and it equals 4. So x cubed, 64. And then I take the cubed root of both sides, and that's where my 4 came from. Okay, and that's it. Let's look at the practice problem C, though, just real quick, just to give you one more bit of practice. That's a 3. Okay, so I can get rid of that and get rid of that, and when I do, I put that on top, and my answer is 4. Square root of that, square root of that. All right, so there's just some things you need to remember, and that is when there is a number in front of the log, it becomes the exponent on our argument. When we have 2 logs added, it's the same as multiplying the argument. When we have 2 logs subtracted, it's the same as dividing the argument. And that's it for Lesson 118.